All right, a word problem. Start my morning off. So we got some guy who's going to a party and he wants to limit his intake because apparently he's worried about his figure. Doesn't sound like much of a guy to me, to be quite honest with you. And look at what he's eating: mushroom crab, mushroom caps, spicy meatballs, deviled eggs. Ugh. Anyways, let's see here. We want to know how much of each snack he can obtain, he can eat. And the deal here is the limitations. 114 grams of protein. It's going to be kind of silly, but we're going to call mushrooms X, we're going to call meatballs Y, and deviled eggs are going to be Z. So mushrooms, actually these are pretty good. We're just going to go with the letters they have. Mushrooms are M, meatballs, we'll go with S for spicy, deviled eggs D. All right. And we'll write equations based on what they have. And the first thing we're going to do is we're going to talk about protein. 114 grams of protein. So I'm going to go through and I'm going to look at everything and see how much protein it has. Mushrooms are 3. Meatballs are 14. And eggs are 13. Now I'm going to go through and I'm going to look at fat. Mushrooms are 5. Meatballs are 7. Spicy meatballs. And where was I? Deviled eggs are 15. And lastly, I'm going to go through and I'm going to look at carbs. So mushrooms are 9. The spicy meatballs are 15. And lastly, the deviled eggs are 6. And I have a system of equations that I can write a matrix with. So that's what I'm going to do. So let me pull up my TI-84 over here somewhere. And go through the process. Second matrix, scroll to edit. I'm going to have 3 rows and 1, 2, 3, 4 columns. It's ACT day. In about 15 minutes or so, I'll stop, start getting things ready for ACT. I get to be a proctor on that. That's always fun. It's not really that much fun. Anyways, make sure I got my equations in right. 3, 14, 13, 1, 1, 4, 5, 7, 15, 95, 9, 15, 6, 141. And then I quit. I go to second matrix. I scroll my happy butt over to math. I look for REF. And I put my matrix in as its input. And ta-da! I have answers. So this dude who is worried about his weight, apparently, which I get, but I'm not going to let that stop me at a party. And I'm not going to be eating these foods, that's for sure. But apparently he can have 6 mushrooms. He can have 5 meatballs. And he can have 2 deviled eggs. And that's what he's allowed to eat. Poor Ron, having to eat stuff like that. All right, so we're allowed to use a calculator on this one. This one's pretty straightforward. Find BC plus 2B. And I really feel like the calculator ought to be able to do this without any issues. So second matrix, let's scroll over to edit. A is a 3 by 2. Give me a second. Anyways, 3 by 2. The elements inside are 5, 3, 1, 0. And by all means, kids, don't just be sitting here watching. Like, play along, get an app on your phone, do something. All right, learn how to use your technology. Matrix B is also a 3 by 2. And there's another matrix on this example. It's matrix C, which is a 2 by 3. Remember, you have to quit every time. You would know that if you played along in class. It's not my fault if you don't. All right, so assuming I typed everything in correctly, we're going to assume that I did. Second matrix B, I'm looking over here at what it's asking me to do. Second matrix C plus 2 second matrix B. Dimension mismatch. Why would that be a dimension mismatch? This may be a case of we've done too much at once in calculator. BC is going to be a 3 by 2, multiplying it by a 2 by 3. So I know it's good. This ends up being a 3 by 3, doesn't it? Aha. That's why. Well, there we go. I actually intended for something to work out on this one, but it didn't work out. The reason I'm thrown off is because I didn't come up with this question. I was expecting it to work, but it doesn't work. This is literally not defined because we're doing a 3 by 3 result and we're trying to add 3 by 2. So it's undefined. I was really expecting that to work though, but I didn't make this question. So there we go. Can't do it. Let's see, number 8, final grade for an algebra course determined by grades on the midterm and final exam. This is the way it was when I was in college. It's not the same anymore. The grades for 4 students and 2 possible grading systems are modeled by the following matrices. Find the final course for student 3. Find the final course score for student 3 for both grading system 1 and 2. So let's think about what we're going to do. We're obviously going to do some matrix multiplication. We're taking this guy right here, which is a 4 by 2. I'm going to multiply it by the next guy, which is a 2 by 2. And we're going to see what happens. Now, if we do it that way, I don't think we're going to get to keep what we want. Or will we? Yeah, we'll have a 4 by 2. So the outside will work. We'll keep these 4 and we'll inherit those 2. And that'll tell us our grades. So this is the way we want to do it. You just have to think about what's going to be kept. We're going to keep these 4 rows and we're going to get these 2 columns. That's what the outside is. First guy is rows, at least its idea of what its rows are. And the second one is columns. And the grades are going to magically be there. All right, so second matrix, scroll to edit. I have myself a 4 by 2. Looks like student 2 is not doing so hot, does it? I think student 2 is repeating that class. All right, 73, 79, 44, 62, 83, 85, 98, 96. All right, got it in, quitting. Second matrix, scroll to edit. B is a 2 by 2. So if you'll notice, you have two competing philosophies here. One of them weights the midterm and the final the same, and the other guy looks to see how much you grew. Anyways, let's see what happens. Oops. I need to clear something. Take the first matrix, multiply it by the second matrix. Let's see what we get. So here's our resulting matrix. You can do that again. Now, what we kept on the side is student 1, student 2, student 3, student 4. And this is system 1 and system 2. I'm interested in student 3. There's student 3's grades. Student 3 is actually best served by the first system because their final grade was higher. So it had more weight. And you can see student 2 is retaking the course. Didn't matter which system. And which system actually worked better? Like system 1 worked better for this guy. System 1 worked better for that guy. But system 2 worked better for the A student at the bottom, oddly enough. All right, each matrix is non-singular. Find the inverse of the matrix. Be sure to check your answer. This is literally one of those give me questions you're not supposed to miss because you get to use a TI-84. You do. So if you miss this, you're that second student. Like, you're going to fail. I mean, this is literally push buttons in a calculator. And you can't say we haven't been pushing buttons, because we have. Anyways, I quit. I bring up the matrix. I press that little inverse key right there. And then I press the magic enter key. And there is my inverse. There are ways of doing 3 by 3s and so forth and much bigger by hand, but they are not taught in Algebra 2. They are not taught in college algebra. They're not taught until you take a course called linear algebra, which you don't take in high school. All right, use the coding matrix to encode the message care. And I don't know why, but I don't have anything typed out here. It's kind of a bugger. Oh, I'm not going to do this for you, by the way, on your test. I might. I don't know. I just don't feel that I should have to. Most of you won't even do this. Like, you won't write it down. So I just don't know. These are not hard problems. I really don't have any pity for y'all about time. That's up to you. Anyways. It is time consuming to type this. All right, so we're supposed to encode the message care. And we have a coding matrix that we're supposed to use. And the way these work is you take your coding matrix and you multiply it by the message. So first off, we have to take the message and we have to turn it into a matrix. So talk about care. I better do that over here so it lines up better. We work down. C is a 3, A is a 1, R is an 18, and E is a 5. That's care. We're going to multiply it by the coding matrix, which is -1, 2, -3, 5. And we're going to get a result. This will be the encoded message. It'll also be a 2 by 2. I was hoping to get more of this done this morning. I don't lack much. Hopefully I can finish it. So I put the encoding matrix in matrix A. I'm going to put the message in matrix B. And then you know what I'm going to do from there. I'm going to do A times B. So second matrix A, second matrix B, and there's my encoded message. So -6, -33. And you know, even if you're sitting at home saying, this is easy, I can do all this, if you play along, you'll be faster, because I'm not going to hear your crap about I didn't finish, Milbrath. You didn't finish because you didn't practice. And that's not my problem. That's a you problem. If you don't finish, it's because you didn't practice sufficiently. All right, here we have, we're supposed to decode. And when you're decoding, you take the inverse and you multiply it by the encoded message. And we're going to have to decrypt it. So we're going to actually have to go back and we have to look at the letters and see what it says. But on paper, what I'd be doing is I'd be taking this inverse and I'd be multiplying it by that thing. That's really all there is to it. Big deal is you put the decryptor in front, or the encryptor goes in front, however you want to think about it. All right, so it's time to edit. Oops, got ahead of myself there. Anywho, I got 2154, 2154. Two, 1, 5, 4. Interesting. I know that 2 is a B, 5 is an E, 1 is an A, and 4 is a D. So, bead. Interesting. That's the cryptogram. Bead. And there you go. I think there's one question left, and it's technically a bonus. This is a bonus, all right? This is definitely a bonus question. It's a bonus because it's asking things that are really beyond the scope of Algebra 2, at least as far as I'm concerned. But this is a 3 by 4. And I know what's happening. You know, a lot of y'all say, oh, bonus, I'm not going to do it. Yeah, but if you're going to college, you do need to understand what's going on here. So you still need to do it. So many kids are like, I'm never going to use this stuff. I don't need the stuff Milbrath's teaching. I don't necessarily disagree with you. But if you're college bound, you do need what I'm teaching. That's what you need to realize. You have to show mastery of the math that I teach at some point in time to get that desired degree. And so just embrace it. It'll make it easier the next time. All right. I'm just checking to make sure I don't have any typos. Now, we're going to do this with reduced row echelon form, second matrix math, double REF, second matrix A. What a weird looking thing, isn't it? You guys haven't seen one of these in class, but this is what it is. Now, how do I decode that? You know, that's the deal. What does this mean? What does that mean? Because the only patterns you've seen that look like this have had one line that said 0 equals 0, and this one has two. So let's talk about that, what that means. This bottom line, it says, literally it says no z is 0. The one above it is about y. It says no y is 0. And this one, this says x minus 7/8 of y plus 3/8 of z is equal to negative 61 quarters. Funny, huh? What this is saying is saying right here is that the value of x depends on y and z. So we're going to take that equation, we're going to solve it for x. X is going to be, we're just doing a shift right, we change signs, 7/8 y minus 3/8 z minus 61 quarters. Now, I depend on y and z. Y and z are any real number. When you talk about your ordered pairs, they look like this. We would put in x, which is 7/8 y minus 3/8 z minus 61 quarters. Then you would have y and you would have z. And usually it says this, y is any real number. So maybe put that. Maybe put a colon or something. Y is any real number, comma z. Z is any real number. But how that ordered triple is written really depends upon the author of the question. I've seen this written numerous different ways, but they all have the gist of this. They all define x in terms of y and z, and either inside or outside of the triple, they talk about the other two being real numbers. That's just how they write them. It's not a standardized system so far as I can tell based on what I've seen in math, but they all talk about the same general things. And that is the last of the extra credit quiz. Remember, your test is Friday. I hope you do well. I sincerely do.